Hello. So, in many applications, one task is highly frequent and the tasks are searching and sorting. We have already covered the searching algorithms and how to write programs dealing with searching mechanism. Now, we will discuss another important task, that is called sorting. Now, sorting as a very fundamental algorithms, but it is being exercised like anything, and many sorting techniques are now known, which they have their own advantages as well as disadvantages. But it is better that if we have little bit review of different sorting techniques, those are available. So, in these lectures, this is the first part of this module, and there will be few more parts, 3 more parts here. We can cover other parts, covering other techniques. So, in this lecture, we will try to first cover what are the different sorting techniques are now known in the literature, and then we will try to learn about very few simple sorting techniques. And in this category, there are 3 techniques are known as simple sorting techniques, which is called insertion sort, selection sort, and bubble sort. So, this is our plan for today. Now, let us start about the different sorting techniques which are known in the field. Now, all the sorting technique can be divided into 2 broad categories. They are called internal and external. Internal sorting technique is basically technique when we apply to data which are stored in a primary memory, that means in computer memory. On the other hand, external sorting techniques is applicable to data when they are stored externally. Externally means it is stored in some tape or device or hard disk like. So, this technique is good, I mean external technique is good for or applicable or useful for when huge data to be sorted, and this is huge data such that you hold the data you cannot bring to your memory, computer memory or primary memory. So, that is why external. So, this technique is something different which is not possible to discuss in this course, rather we will limit our discussion to internal sorting technique. Now, all internal sorting techniques again can be categorized into 2 classes. It is called the sorting by comparisons and another is called sorting by distributions. Sorting by distribution, one sort of technique it is called without any key comparison it is called. So, it is basically sorting with key comparison and sorting without key comparison you can say. Now, when we say about sorting by key comparison, there are again 4 different principles are followed. One called principle of insertion, principle of selection, principle of exchange, and principle of enumeration. Now, so all sorting techniques these are the basically broad classification or taxonomy of different sorting techniques, and based on these different principles there are many sorting techniques are evolved. Now, again the different sorting techniques demands the data should be stored in a particular structure. Now, altogether any one of these 3 data structure like arrays, linked list and tree can be considered. So, that is what I want to say, that if your data stored in the form of an array, then a particular type of techniques can be applicable, not all. Similarly, if your data stored in the form of a tree, then you can apply a certain techniques, not that all techniques can be applied to there. So, depending on the data structure, a different sorting techniques are to be followed. While we are discussing about different data structure like linked list or tree, we have given some hints about that okay, sorting is possible and how it can be there. But now we will discuss about a detailed procedure about different sorting techniques when the data is stored in a different structure. Now, okay, so this is another consideration. Now, let us see all internal sorting techniques, how they can be further subdivided into different types. So, any internal sorting technique as shown in this slide can be based on sorting by comparison and sorting by distribution. Now, let us come to the sorting by distribution. Their radix sort, bucket sort and counting sort are very popular, and okay, people like it. And so far the sorting by key comparison, there are many different techniques are known, and based on the principle of insertion, there are technique called state insertion sort, binary insertion sort, two-way insertion sort and list insertion sort. Now based on selection, state selection sort and tree selection sort and heap sort. Based on exchange, the sorting technique is called bubble sort and quick sort, and there is a based of principle called enumeration, it is called the merge sort, simple merge. And sorting distribution, I told you it is a radix sort, then these are the bucket sort and counting sort. This external sorting technique, there are different sorting techniques are for if you want to store the data which are stored not in computer memory but in a secondary storage. Now as you see, there are many sorting techniques, it is not possible to cover all techniques. However, we will limit our discussion to certain techniques which are the fundamental sorting techniques, and it has a very, it is basically it is interesting to study. So I have mentioned that this simple insertion, then selection, heap sort, bubble sort, quick sort and merge sort, all those things, all the sorting technique will be covered in this course. So for many more detailed discussion about many other techniques, so I refer to you this book. In chapter 10, there is a detailed discussion of different sorting techniques are available. So you can follow this book and then learn much more. Now the techniques that we will cover in this lecture, or rather in this course we can say, these are the technique will be covered. I have already given idea about that. This is basically based on the sorting, simple sorting technique. These are the technique is basically based on different principle called improved sorting technique, and these are the basically technique which is later on devised is called the advanced sorting technique. So all the sorting techniques is categorized into three different criteria, as in simple, improved and advanced. So today let us first discuss about simple sorting techniques. It is easy to understand actually, because that is why that their name is simple. So in this category, in simple sorting technique, there are three techniques we have chosen. One is called insertion sort, selection sort and bubble sort. So first we will discuss about insertion sort. Now here the sorting of elements which are stored in an array, they also can be equally applied if the data stored in linked list, but I will limit the discussion with reference to the array data structure. Linked list in the same way you can extend. If you understand the array, then the linked list also can be understood easily. Now let us discuss about the insertion sorting concept. The idea is that the elements are stored in an array and you have to have several loops. It is called the passes or iterations, whatever you can tell. So in each iteration, so it is, if it is an ith loop or in ith iteration, so the element ki needs to be placed in its proper position. Now how the kith element can be placed in its proper position, I can tell you the idea. Say suppose at any moment this is the already partially sorted part of the list, and here in the I plus 1th element, that is the element that you want to place it. Now this element can be any this place or it can be anyone. Now if this element is, the value of this element is any within these values, that means this is the lowest one, this is the highest one at the moment. If this values is within this one, then this can be placed here. If this value is greater than any value in this list, then it will remain in the same place. That is the idea. Now what exactly the idea that you should follow is that first of all we have to see this ki, then we compare this one whether this value is greater than or you can say that okay, whether this value is greater than or equals to this value. If it is there, then we go to the next position, and it will come on whenever we say that one value which is less than this value, then we can place this value there where we find this test. Now, in order to place it, what is the idea is that you need to swap this position to this position, or you can move all elements from this position to this one. So, movement of elements is required, because in order to place this element here, we have to make a place shifting all the elements once towards this direction up to this one. So, there actually the comparison as well as shifting of elements is required. Now, this is the procedure, it is explained in details here. So, if we find that this is the position, we can move this and we can place the element here. So, this is the concept that is there. We can understand this concept better if we illustrate with some example, and here is the algorithm that you can think about. This algorithm consists of two parts. First of all, you have to find the element in which position it should be placed. So, this part is discussed here. Then move to the right one place all the keys, because you have to make a room for the new for the element to be placed there, and then you just simply place the element there. So, three steps are there, which is basically written in the form of an algorithm. You can follow this algorithm so that you can understand better. Now, let us illustrate this with a simple example so that you can understand this concept better, starting from the initial loop like. And here is a, suppose this is the input list that is given to you, which is not in sorted order, right. Now, first pass, that is the default only. So, this will remain in the first location because we do not have to compare. So, we can start our traversal from this point only. So, this is basically first loop or iteration 1 we can say. Now, here what you can do is that this 6 will be compared with 5, and we see that 6 is greater than, that means we do not have to move. So, we can keep it here. So, after the first iteration we can get it, then we can take the 4, the next second iteration. Now, we see that 4 is compared to 5. So, we can say that 4 should be placed here. Then what you can do is that 6 onwards and 5, 6 onwards, you can move this till this 4th position, right. We can move into, so that 5, 6 can be moved here and 4 can be placed here. Next come to 7, we can see that 7 should be placed here because all elements starting from here, it come here, so it placed here. 9 also same thing. Now, when we will come to the 5th iteration, the element 8 is coming, we start here and then place the location here. So, moving of 9 here and then place the location here, and this way it will continue. Now, here again there is an alternative idea also that you can follow. Sometimes it works also, but it is not guaranteed that this work better than this work, whatever it is there. The idea is that, alternative idea is that here what I am doing, in any iteration we start from the starting location and compare in this direction. Alternatively, we can start from this location and go this direction to find to this one, but under any way you have to find that within the partially sorted list the new element that we are considering where it should be placed. So, if you can start from here or if you can start from here, that is not an issue, okay, but you have to find it, and movement will be always there, because whenever you see that this element should be placed here in this sorted part, then we can move accordingly fewer elements towards the right. So, that procedure you can consider. So, this about the technique, and then so far the complexity analysis is concerned, you can check that there are 3 cases. One case is basically when the input list is already given in sorted order, then complexity that is required is n-1. Here n-1 is basically I am telling about how many movements that is required. So, a movement is the very expensive procedure here. Comparison is also there. So, comparison as well as movement altogether, it basically says that n-1 total number seed is required. Now, if the input list is sorted but in reverse order, another case, you can see that total number of movements as well as comparison, it will take around this order. Now, input list, if it is in random order, whatever the case that we have discussed, it is basically belong to that case, then it can be proved that number of runtime that is required is basically in this order. So, this is the number of movements and comparison that is required. Now, a thorough discussion about this analysis you can follow in the book Classic Data Structure, so that you can understand how this calculation comes, but it is not possible to discuss the detailed calculation because it is time consuming and too many discussion is required. Anyway, so you have understood about the one simple sorting technique called insertion sort, and I can express the complexity in this big O notation. You can check it. In the best case it is, worst case and average case, this is the big O notation. Now, let us come to the selection sort, another simple sorting technique. This selection sort is the basic principle or the concept that it follows can be expressed like this. So, you can start many iterations. Here total n minus 1 iterations will be needs to be considered. So, now first we have to consider the entire list, that is the starting iteration. We can say the first iteration. In this first iteration, you have to find which is the smallest element in the list. Then you can search for the entire list to find the minimum values in the list, and then whatever the minimum values are there, we should place into the first location in first iteration. But whenever you place it, then it needs to be swapped. So, the element which is in the first location and element, if the minimum element is available in the ith location, so we can swap the element between ith location and the first location. So, this is the first pass, we can say. The second pass we have to consider starting from the second position of the array to the rest. Again we can find the minimum in between position 2 to n, and then find the minimum. Again, say suppose the minimum is found at ith location, then we have to swap the element between the ith and second location. So, this way if we continue till n minus 1 pass, the last element will be automatically sorted in that position and we can stop it. So, this is the basic concept that is followed here and which is explained in this figure. So, here suppose initially this part is already sorted, then we have to find the minimum, next minimum in this position. So, what we can do is that we can search for the minimum value within this part, okay, and let it is available there. So, what you can do, this ki and kj needs to be swapped. So, kj will come here, ki will come here. So, initially up to this part was sorted, now after this part is sorted. So, this way you will increase up to this one, then we can complete the elements to be sorted. So, this is the concept that you can follow. Now, here let us consider the algorithm that you can think about. This is the algorithm that is given to you. The algorithm consists of swapping, that is the technique that you can consider. This is for swap method. There are many other swap method also you can consider, and here is basically you have to find the minimum value. So, it basically minimum, that is I select minimum, and then how the select minimum algorithm is explained here. And then this basically after selecting minimum, swapping, and then this iteration, as you see there is a loop for I equals to 1 to n minus 1, because I told you n minus 1 number of iteration is required, so you can implement it. So, this basically the idea. So, this algorithm is easily you can write program, not necessarily to write generic program, you can write in simple program taking array as an input, and then you can write it, and later on you can make into a generic version, so that any other type of data type can be considered for sorting. So, again that is left as an exercise for you, so you should study, you can practice it. Now, here is an illustration that you can think about. So, how it works. So, this is the starting array that you can take into account, and here the first pass, that is the first iteration. So, fourth element, okay. Now, in this iteration what you want to do is that which is the minimum element available in the whole list, we have to find it first. We see that minimum element is present here. So what you can do is that 4 and 1 should be swapped. So 1 will be placed here and 4 comes here, and this basically the part. So up to this part is now sorted. In the second part, so we are here, and then we have to find which is the next minimum value, that is in this part. Now we see that 2 is the minimum value, then we can swap and we can bring it here. So this is up to this part and so on. So it will continue. Now again there may be more than one element. See, array can contain duplicate elements, so it is quite possible that 2 or more elements are same value are present in the list. Then how we can do the sorting? So it is the same we can apply, but whenever the first occurrence, that means first minimum of the past will be considered, and then we can replace it. So this way this algorithm gives you in place sorting algorithm, also called stable sorting algorithm. There is a concept called in place and stable. You can consult the book Classic Data Structure, you can find the concept about in place and stable sorting techniques. Anyway, so this idea, whether as a very trivial case or very extreme case, you can consider how this sorting algorithm works or not, even insertion sort also. Here we have considered the random order. You can consider any other order, ascending, descending order, that is the test case, you can check it. And further is that you can consider all elements are equal, then whether this will work or not. So it will also work, you can same procedure you have. So the algorithm, it is written in that way that it can take all possible cases and then it can work. So you can write the program and convince yourself that okay, it is working for all possible cases, it is there. Anyway, so this is the idea about the selection sort, and let's come to the complexity analysis. If the list is already in sorted order, then the total number of comparisons as well as movement, those are required, can be calculated as n into n minus 1 by 2 is the one case. If it is in reverse order also, it takes same amount of running time, and if it is in the random order, it also takes. So whatever be the cases you see, it basically the same complexity it takes. And here is the table that you can consider about summarizing the complexities of all the cases: best case, average case, and worst case. These are the complexity, that means asymptotic complexity or running time. This is the actual calculation. The details of the actual calculation that can be had from the book. So I advise you to study the book if you are interested how this calculation come there. So these are comparison and then total complexity time that is required there. Okay. So this is basically the simple one sorting algorithm, selection sort. Now I will discuss about another simple sorting technique. It is the bubble sort. The bubble sort idea came from the bubble. As you know, those are the lighter bubbles should go to the top, and then heavier bubbles should go to the bottom. This is the concept, it is there. So here basically all lighter bubbles will go up, and then heavier bubble will come there. So finally at the bottom it will store the heavier bubble. Now here lighter and heavier in the context of numbers, if you say the smaller number are the lighter bubbles and then largest number are the heaviest bubble. So that is why. So this means that in this bubble sorting technique, the idea is that all the heaviest numbers in each iteration go towards the down. If we consider that bottommost part of the array or rightmost part of the array store the largest number onwards, and then the leftmost part of the array or the top position of the array store the smallest element. So this is the idea about this one. Basic principle that it is follows in this category. Now let us see one example so that we can how we can do it. So earlier sorting technique consider only one loop, but here actually we need two loops. Now here actually let's see how this technique can be better discussed. Here is an algorithm. This algorithm considers the swap. This is the swap method you can use because we need the swapping. I'll come to the discussion how the swapping can be done. And this is the algorithm. Okay, better I can come back to the algorithm later on. Let us first discuss about the technique so that we can discuss about the algorithm. Now here suppose this is the input list, right? and then these are the different passes that is required. Finally, we can reach to the output list. Now, in the first pass, as you see, the idea is basically we compare the two adjacent elements. So, 55 and 77 for example here, and if we say that they are not in order, they are not in order means if we say that the previous one is greater than the next one, then they are not in order, because we want to make in ascending order. The ascending order says that in order means that the previous one should be lower than the next one. Even if equal number, then we can do anything, we should not think about it, we keep it there. So, we can say that okay, previous one is greater less than or equals to the next one, then we can say in order. Anyway, so here we see 55 and 77 in order, so we do not have to do in anything. 77, 99 also in order, so do not do anything. Now, whenever we come here 33 and 99, what we say that they are not in order. So, what we can do, that we can interchange them or swap them. As you see, this 33 should come here and 99 should come here. So, now 99 comes here, then 99 and 22 we have to again compare, then we can see that they are not in order, because 22 should come here. So, 22 go there and 99 will come here. Now, you see 99 is coming right this way, then when 99 is here, 88 is here, then we say that they are not in order, and then 88 go there and 99 will come here. So, 99 is come here now, right, and then 99 is here, 66, you can see that it is not in order. So, we can 66 can be placed here and 99 will come here, then 99 is here and 44, we see that 99 is greater than, not in order. So, 44 and 99 should be swapped, it is like this. So, ultimately 99 comes in the right. So, this is basically heaviest bubble, it comes there, and in between whenever swapping the elements is reorganized this way, we can see the those are the smaller bubble, actually the lowest element is moved this direction, because here you can 22 moves to here, 33 moves there and so on. So, all smaller element moves there. So, this completes the first pass. So, after pass 1 we can this one. Now, for the next pass what we can do is that, as this part is already over, so we should not consider the next part, we will consider, we will limit our discussion to the this list only. So, each pass, as you see, the size of the arrays are decreasing in numbers. So, this the same procedure you can follow again, the starting from here, and you can see the 88 is the heaviest bubble, so it can come here, and this will continue, and if the total number of elements is 8, then it takes around 7 passes. So, in the after 7 passes we see that all elements are stored in this order only. So, list is already finished, and this will give you the output list, that means element is in sorted order. So, this is the idea about sorting technique, and this idea is basically implemented by an algorithm. This algorithm is basically mentioned here. This is an algorithm which you can follow to write the code. Very cryptically is very written in a very nice manner, so that if you can follow it, and then writing the program, if you follow this algorithm and write the program, you will be able to understand better. And then swap, this is the one method you have to define according to this, right, you can define, and then you can check that it is working. Okay, so this is left hand exercise, so that you can write the program immediately after learning it, so that you can understand, other than other than your basically taking it by manually practicing. So, better write the code and then practice it, you can store the number as an integer and then solve the problem. Now, let us come to the complexity analysis. There are again many different cases are there. As earlier also we have discussed about whether list given in the sorted order, you will see that the complexity will come into that way, and if it is reverse order, you can see this one, and input list in random order also this one. Now, this is the idea that is right, but here bubble sort technique, if already in sorted order for example, now it is taking unnecessary, because in that case there will be no movement of bubbles, the heaviest movement always in their position, lightest movement always in their position, so no movement. So we can just have a click there, we can keep a flag. If initially the flag should be 0, indicating that okay, we have to repeat the pass. Now whenever we see there is no movement or any swapping, then we can make the pass at the end of the one iteration, that pass can be 1. So whenever the pass is 1, then it will not repeat the same procedure and it will stop. So in that case only one pass is required, and in one pass only n number of comparison is required. So that way this complexity can be reduced from n square to n only. So this is a particular modification of the bubble sort, and this modification famously termed as funnel sort. In many books it is written as a funnel sort. In the classic data structure also you can have the idea about funnel sort. So a modification of this algorithm you can find in the book. I have not discussed here in this lecture. Now it is the summary of the different complexity that we have discussed here. So the best case, number of comparison and total complexity, that is the running time complexity we can say. Average case, and in this case is order of n square, and if you modify this one, then this can be made into order of n, but the original bubble case is basically order of n square without modification. So these are the different sorting technique that we have discussed. They are basically belongs to the simple sorting technique, and for many more details discussion and few integrated point regarding the different sorting technique and twist, which is very important for many competitive examination, that you can clear from this book as well as. So I advise you to follow this book for further study. Okay, with these things I would like to stop it here. I will discuss the other sorting technique called the improved sorting technique, which will be discussed in the next lecture. Thank you very much.